Hey guys, this is an examples video on the second derivative test for local extrema, so it's how to use the second derivative to find max and mins. So I will just jump right into it and start with these examples. So we want to use the second derivative test for local extrema only to find the local extrema. So I've talked about this in my last video, but I'll just give you a refresher of the process here. So the first thing that you need to do with this is find the first and second derivatives. So I'd recommend that you pause the video, find those, hit play when you're ready to see the answer. So for this one, I think actually the easiest thing to do here is to do a little bit of extra work on the front end. Multiply all of this out because you could use, the product rule here, but I don't know, I just don't want to. It'd be less time for me just to kind of factor this out and or multiply it out and all that. So I am just going to notice here that this is really x to the fourth minus 2x cubed plus x squared, and I'd much rather just take those derivatives. So now I'll take the derivatives. Okay, so there's my first and second derivative. And so what the second derivative test for extrema says is that I have to find all of the critical points here. Now, notice that there are no points where this will be undefined, so I just have to set this thing equal to 0 and solve for it. So let me do that. Okay, so now I have a little bit of a pickle here. Just in case you weren't sure, you can totally factor this. So if you didn't do that, make sure that you have done that. Sometimes people think that you have to use the quadratic formula here. You totally don't. So it factors. And so now I can see what my critical points are. So I have critical points at x equals 0, x equals positive 1/2, and x equals 1. Okay, so now that I have my critical points, let me clear some space. And so once you identify those critical points, so that's from the first derivative, then you plug those into the second derivative. And all you care about is whether or not that's going to make the second derivative positive or negative. So you could, if you wanted to, you can actually evaluate this. And so for instance, if I did just f double prime of 0, that would obviously equal 2. But all you care about is this positive or negative? So that's clearly greater than 0. I could do this for the others. But just FYI, it's not necessary to actually know what this answer is unless you just happen to be kind of working it out. So don't lose sleep over this part. The important part is it positive or negative? And so I talked about this in another video. So I would highly recommend watching the kind of the theory video on this if this doesn't make sense to you. But what this means, right, is so at 0, this whole graph is actually concave up, which would then mean that there must be a local minimum here. And then when the graph is less than 0, so when f double prime is less than 0, that means that this is concave down, therefore 1/2 is a maximum. And so on with f prime of 1, or f double prime of 1. So this I went into a lot of detail with, and the reason that we like to use this test is just because it can be faster. But if you want to compare it to the first derivative test, just to kind of wrap your head around all of this, I'd highly recommend watching the other video. Okay, so now what I want you to do is I want you to try the second derivative test on your own. So if you want to plow through the whole thing, that's great. I can give you some guided steps. So first things first, you're going to have to find the first and second derivative here. Go ahead and do that and then hit play when you want to see the solution. Okay, so here are my two derivatives. Now for the first derivative, you have to use the chain rule. And now that we have this derivative, now you're going to have to use the product rule to get to the second derivative. So just make sure that you've got that. Now, the next thing that we need to do is find the critical points. So I need to set this equal to 0, and set my first derivative equal to 0 and solve. So if you haven't done that yet, pause the video, hit play when you're ready to see the solutions. Okay, so now working with this domain, so all of my technical solutions to this are going to start at, so negative pi over 2, 0, pi over 2, pi, and 3 pi over 2. However, I want you to notice this is a closed domain. So I've got other videos talking about closed domains. So when you have a closed domain, you can't actually count the endpoints in your critical points. So even though this is true, they're not true definitions of the critical point in a closed domain. So we're going to discard those. So these are the three that we're really curious about. So obviously, if I were trying to find any absolute global extrema, I would plug in the endpoints into this, into the original function. I have a whole video where I break this down. But in this video, I'm just trying to utilize the second derivative test for local extrema. So I'm not going to worry about the endpoints in this. I'm just trying to practice that test. So now I need to plug these three critical points into the second derivative. And all I care about is whether or not they're positive or negative. So if you haven't done that yet, pause the video, take your time to figure that out, hit play when you're ready to see the solution. Okay, so now let me show you. F double prime of 0, that will end up being something less than 0, so it'll be negative. F double prime of pi over 2 ends up being something positive, and F double prime of pi ends up being something negative. So now I can make my conclusions. So based off of that second derivative test, those would be my conclusions. Again, if you want to see just the breakdown of all of that, consider just taking a look at my other video to get that whole review. Okay, so now for this last one. I'll warn you, this is a bit of a slog from an algebraic standpoint. So to begin, I want you to find the first and second derivatives. So go ahead and do that and then hit play when you're ready. Okay, so I actually want to do this in a special way. So first I'll show you the first part of the first derivative. So here what I've done in this step is I've just applied the product rule, but there's a whole lot of cleaning up that I can do. So I want you to push this as far as you can algebraically, and I'll give you a hint. You're going to want to factor out the e to the negative x. So take this out as far as you possibly can, and then when you're ready to see all the steps that go into it, hit play. Okay, so first things first, I just changed the sign in the middle here. And now what I'm going to do, I'm actually going to factor out this e to the negative x, which is going to leave me with this 2x minus 1 minus this x squared minus x. So now I just need to collect any like terms in here. So this is going to equal e to the negative x times, let's see, this will come out to negative x squared plus 3x minus 1. And in general, I prefer to have my x squareds be positive, so I'm actually just going to factor out the negative out here. So this will equal negative e to the negative x times x squared minus 3x plus 1. Okay, so now, before we go any farther with this, I actually want to go ahead and find my critical points here, because this is going to take some time. So notice e to the negative x, this by itself will not be 0, so we don't have to worry about this. But this unfortunately does not factor. So you're going to have to use the good old quadratic formula to figure this out. Sometimes when you're doing these, you have to get your hands dirty in the algebra. It's just fact of life. So I'm going to clear some space. And now I'm going to use the quadratic formula on this guy, noting that my a is equal to 1, my b is equal to negative 3, and my c is equal to 1. And you know, I'm feeling nice today, so I'll go ahead and repeat the quadratic formula for you, just in case you're rusty. Okay, so here's what we've got to plug in and work out as far as we possibly can, so I'll go ahead and show you the steps for that. Although you should already have this worked out and get the decimal answer before anything, so maybe figure that out, then hit play when you're ready. Okay, and so this should really equal, so sorry I'm getting a little sloppy with my notation here. Okay, so here are my 2 critical points. So they're not beautiful. And sometimes that happens with calculus. Not all math is going to end up having these nice even answers. So these are my 2 critical points. So what I want to do is clear some space and just note this. So let me do that. Okay, so now that was just the first derivative. So now we got to find the second derivative. So go ahead and find that. And once again, I want you to try to break it down as far as you can algebraically. And I will show you the steps for that whenever you're ready to hit play. So there are all my pieces just from using the product rule. And so now, once again, you're going to want to factor out this e to the negative x. So we'll factor out this negative e to the negative x and just kind of see what we're left with. Okay, so now I have multiplied this -1 by this, so I just kind of tried to clean this up a little bit. So now I want to factor out my e to the negative x just to see what I'm left with. And so now I can collect my like terms. And so check this out. This actually factors, so that's a nice little bonus there. So now I have worked out my second derivative to make it as nice to look at as possible. So this is a very common thing that you have to do in calculus, is really flex all that algebra. So let me clear this all off now so that I can just summarize this. And by the way, with these videos, so you are intended to kind of pause this and write these steps down and make sure that it all makes sense on your own end when you're doing this. So now I'll clear off some space. So the entire reason that I did this was just to make this easier for me to plug in the critical points, because ultimately I need to figure out, is this positive or negative, and I don't want to really mess with this for too long. So it's kind of better for me to do the algebra and figure this out, and then I can figure out at least the signs of this. So if I were to plug 2.618 into this, so 2.618 minus 4, this will be negative, and then this will be positive. And then this, when I plug 2.618 into this will also be positive. So I have something positive times something negative times something positive times something negative times something positive. So this will ultimately end up being less than 0. So that tells me that 2.618 is a local max. Okay. And so now, for the other one, so I can go through this same exercise, right? And if I plug this in, so if I just look at the factors, so 0.382 here, this will still be positive, this will be negative, and this will be negative. So I have something positive times 2 negatives, so this whole thing will end up as something positive. Therefore, and so now we're done. So like I said, it's totally normal to have to actually spend all that time doing the algebra when you're in calculus. It's the fun and maddening part of it all at once. So that will cover this particular series. Thanks for watching. I'll see you guys in another video.